On today's review, we're going to focus on transformations, and this is where on the quadratic transformations where you take the parabola and either shift it straight up or shift it straight down or left or right, or we make it wider or we make it skinnier, or we flip it over the x-axis. It goes from being a smiley face to a frowny face. So that would be a reflection over the x-axis when we just flip it. And then, of course, if we change the number on the end, it shifts it up or it shifts it down. The bigger this number gets, the skinnier it gets. The smaller this number gets in front of the x squared, the wider it gets. Those are kind of backwards from what you think they're going to be. So the easy versions of these transformations is where they give you the parent function and they give you a second equation. And you just put them both in the calculator and see what changed from the first one to the second one. The parent will always be the first one, okay? And then whatever the new one is, even if they give it to you first, that's the new one. So you just see what happened. Did it shift up, shift down? Did it get left or right? Did it get wider? Did it get skinnier? Or did several things happen, right? Sometimes it's more than one thing that happens. Now, the harder versions of these transformations is when they don't give you the two equations. Instead, they say, hey, take the parent function, whatever it may be, and add 3 to it. Or take the parent function and add or subtract a number inside the parentheses with the x. Or multiply by a number out in front. Okay, so those are the things that they do with these shortcut. I call them shortcut notes. They're kind of like shorthand. It's just using the symbols. So if they take your function and you add or subtract at the end, okay, this is your up and down motion. Okay, if it's a +3, it goes up 3. If it's a -2, it goes down 2. So this is the good kid who's outside at recess who does what he's supposed to. +3 is up, -2 is down. Now, if it's inside with the x, remember x's go left and right on the x-axis, right? So this is a left and right movement. So if they add or subtract inside with the x's, that's going left or right. The one on the end, on the outside, adding and subtracting is up and down. Now remember, this is the kid who's bad, who's inside at recess, because the parentheses are kind of like my schoolhouse. He has to stay inside at recess. Since he's the bad kid, instead of going left 3 like we expect, because -3 is left, he goes right. Okay? If it had been a +2, instead of going right like he was supposed to, he went left 2. So this is a right 3 movement. Okay? So this is the opposite. If it's negative, you think he's going to go left, but instead he goes right. If it was a positive that you're adding, then instead of going right, he goes left. So this is the opposite kid. Now, if you multiply by a number in front of the parentheses, okay, if I multiply by a number bigger than 1, it's going to get skinnier, okay? If I multiply by a number smaller than 1, 1/2, 1/4, 3/8, anything smaller than 1, it gets wider, okay? Kind of does just opposite what you think it's going to do. And then, of course, multiplying by a negative in front changes it from a smiley face to a frowny face, because we went from a positive A number to a negative A number. And that is reflection over the x-axis is the fancy word for it, because it literally flipped over the x-axis. Sometimes they'll use the word flip, but most of the time they'll call it reflection over the x-axis. Now, we did these with quadratics, but we can also do them with linears. We didn't do a lot of the linears at the time because I knew we'd come back and do it in our review. So here we go with the linear transformations. They are very, very similar. So a linear transformation, again, they're going to compare it to the parent, which is y equals x. So the easy versions of these is they give you this equation and they give you a new equation. You put them in the calculator and see what happens. Did that line just simply shift up or shift down? Did it get steeper or did it get less steep? Okay, those are the types of things that we're doing. So if it's a positive number, it's going to go up. If it's a negative number, it goes down. If this number gets bigger and bigger, it's going to get steeper. If this number gets smaller all the way down to 0, it gets less steep. And then, of course, when it gets down to 0, it's perfectly flat. So smaller is flatter, bigger is steeper. The number on the end shifts it up and down, except my y-intercept. It shifts it up the y-axis or down the y-axis. So all that does is take my line and shift it up or shift it down. Changing this number here makes it steeper or less steep. All right, so the easy versions of these, again, are where they give you two equations. You put them in the calculator to see what changed from this first parent function to the new one. Now, if you've never put y equals x in the calculator, this is what it looks like. It's this one right here. It's a positive slope, and it's just going up right through the origin. It's doing that. Now, the harder versions of these is where they give you the function notation stuff again, but these are just like we did with the parabolas. If you're adding and subtracting on the outside, this is the good kid who does what he's supposed to. This is up 3. If it was a -2 on the outside, it would be down 2. So this thing on the linear does the exact same thing as my parabola, right? Up 3 if you're adding and subtracting on the outside. So this is my up and down motion. If it's inside with the x's being added and subtracted, that's your left and right movement. And again, this is the bad kid inside, so instead of going left 3, he goes right 3. So this is left and right, but he's the bad kid and does the opposite. This is the good kid, up and down. So outside's up and down, inside with the x's is left and right. Now, this is where it's different from your quadratics, okay? This one, if you multiply by a bigger number, the line simply gets steeper, okay? If you multiply by a smaller number, the line gets less steep. It gets flatter and flatter. So bigger number gets steeper, smaller number is less steep. And then, of course, multiplying by a negative makes it going from a positive slope to a negative slope. So that's my reflection over the x-axis. If you look at this line right here, this bottom part of the line flips over the x-axis, and if you look at the arrow coming up on this side, it flipped over the x-axis on the new one. So this part of the line flips over the x-axis and comes down here. This part of the original one flips over and comes up there. So it went from being a positive slope to now being a negative slope. So anytime you go from positive to negative, it's just reflection over the x-axis, whether it's linear or quadratic. But if you want to look at the picture, it went from being a positive to a negative. Here we went from being a positive smiley face to a negative frowny face, but it's a reflection over the x-axis anytime you multiply by that negative. Okay, but the good news is these are identical. These are up and down, these are left and rights. You're either just taking the line, shifting it up, or shifting it down, or you're shifting it left and right. Doesn't change the steepness. These things are the ones that change the steepness. Okay, so there's a little review on transformations. Let's go look at today's worksheet. We're going to do the front 2 pages. So the first 3 are very easy because these are just give me questions on in the calculator. Just put the whole thing in. There's no A, B, C's, no X's or Y's. Just put it in the add subtract screen. Square root of 20. Got to know where these symbols are. Go stick it in. And then we're just going to simply go find the answer to that. Plus, when you put it in the calculator. Now, hopefully you've done these enough. You can go put them in the calculator and go do this and then just check your answers. This wound up being approximately 4.4721. And then I put each one of these in the calculator and check to see if it matches that same number. Now, be careful, because sometimes when y'all put these in the calculator, you think that this is the 2 in the crook. But it is not in the crook. This is just a big 2 times the square root of 7. So don't put the 2 up here in the crook. This is not what we are doing, okay? It's just a big 2, plain old 2, times the square root of 7. So make sure you put them in the calculator correctly. Just write down the numbers or just look in the calculator and find one that matches that. And that would be the answer. And of course, this will wound up being D. If you have not done these, pause the video and go do them. Hopefully you're coming back and checking to see which one it is. And this one was C. And this one wound up being D. So those are gimme questions on the STAR test. You're not going to have a lot of these, but you'll probably have at least one, right? So get those easy ones right. Here comes the transformation. Describe the transformation of the parent function. They did not give us the parent function. They just gave us the new one. Okay, now if you remember what the parent function is, y equals x squared, you could put that in the calculator and then put this one in the calculator and just see what happened. So this is an easy one if you remember the parent is y equals x squared. And then just put the 2 in the calculator, see what changed on this one. Now if you don't remember, this has got my multiplication out front. So if I multiply by a bigger number, my parabola is going to get skinnier. Okay, so this is skinnier. And then let's see, inside with the x, this is the bad kid. So instead of going left 2, it's going to be a right 2. So I just make a note what's happening. So that made it skinnier. This moved it right 2. And then adding, subtracting on the end, this is my up and down, and up 1 because he does what he's supposed to. So up 1. So I'm going to ignore the skinnier for a second and just look for right 2, up 1. So I don't care about this. I'm looking for right 2. Nope, that said left 2. Left 2, nope. Right 2, up 1. Yep, so I'm going to keep those 2 pieces. And this is right 2, up, oh, down 1. So that's not it either. So this is the only one that even works with the right and the left and the up and down. And it's stretched by a factor of 2. If I made it skinnier, did I stretch it up and down and make it skinnier? Yes, so stretching it is going to make it skinnier. Had they used the words compression, so stretching is pulling the 2 pieces apart and making it skinnier. Had they used the word compression, that would be like taking it and pressing down on it and making it wider. So, but they didn't use the word compression, they used stretch, so that's going to make it skinnier. So that did work. And of course, we're multiplying by 2, so that's the factor that we're doing it by. So anyway, long story short, even if you don't do the stretching part, the only one that was right 2 and up 1 was C. So eliminate answers as you can. Describe the transformation. Again, this is another equation because there's no f's in here. I can put this in the calculator. But if you want to compare it to the original one, it was y equals x squared. So if you remember what the parent one looks like or where the parent one is, you can do this. So when you're doing the graph on it, you have the new one on there and you can visualize the parent one look just like that. It's always crossing right here at 0 and it's a smiley face. So there's nothing in here that has a negative in front of it, so it did not flip. And this is inside with the x's, so instead of right one, this is the left one. So I'm just going to make myself a note of what happened. And this is down 3. This is the good kid at recess. This is the up and down. This is the left and right. So left 1, down 3. Bad kid inside at recess does the opposite. So I'm looking for left 1, down 3. Right 1, nope. Left 1, down 3, yes. Flipped, no, nothing about flipping. And even though in this one it has the left 1, but it doesn't have the down 3. So the only one that had the right numbers on it was C, left 1, down 3. There we go. Now remember, these are not your easy 30. These are all harder questions on the STAR test. Describe the transformation from the parent function to this one. So again, if you remember what the parent function is, you can just put it in the calculator, and then just put this one in the calculator and just see what happened. Now, multiplying by this negative in front is going to flip it. So I need to have a flip in here. So I'm going to write flip. It's going from a smiley face to a frowny face. I'm multiplying by a 2. So when I get a bigger number, it's going to make it skinnier. So I'm going to put a little skinny thing here, right? And then this minus 1 inside with the x's is right 1. So I'm going to write right 1 over here. And this is down 2. Okay, so I'm going to focus on right 1, down 2 first. Left 1, nope. I'm just going to eliminate answers. Right 1, down 2. I'm going to keep that for a second. Right 1, up 2. No, that's not what I said. I said right 1, down 2, so that's wrong here. Left 1, no, we weren't going left. We went right. And I think that's all of them, right? So what's the only one that even worked? And this flipped, and it was stretched by a factor of 2 because that's stretching it when I pull it up and pull it down. So that was B. All right. Another transformation. Again, they give you the new equation. So I have a new equation. I just got to remember I'm always going to compare it to the parent function. So multiplying by a negative in front. So if you put this in the calculator, it literally flipped over the x-axis. You could see the picture if you put it in the calculator. So A, it flipped. It went right 1. And you can look at this picture and see that it goes right 1. And it went up 3. Right 1, up 3. So one, you could go through and look for flip. No flips in that one, get rid of it. That one's flipped, that one's flipped, there's no flips in this one. And then right 1, up 3. Right 1, up 3, yep, it's that one right there. So we're just looking to see what happened. Literally put these two in the calculator, but you got to know we're always comparing it to the parent. And you got to know what the parent equation is that they don't give it to you. So these are harder ones. Given the following graphs of the two functions, which statement must be true? So the statements down here are that shorthand stuff where you have the new one, f of x is the parent, and the new one is g. And what happened to g from here to here? My vertex, it did not flip, right? It's still a smiley face, but the vertex went from here to here. So it started here, and if you count, it went down 1, 2, 3. It went straight down 3, and that's all that happened. It didn't go left to right, it just went down 3. So down is on the outside, up and downs are on the outside. These are inside, these would have been left moves, and they did not move left and right. This is up 3, this is down 3. So which one is it? It's B. And again, these are the harder ones because you have to know what those symbols mean. All right, another page. More transformations. Oops, get my paper together. There we go. Okay, so given the graph of the parent function, y equals x squared. So they gave it to you here, y equals x squared. There's the parent, here's the new one. So remember the parent is starting here. Now, did they flip? No, they're still both smiley faces. But the parent started off as a vertex right there. So to get to this one, we went left, 1, 2. So I'm going to do left, 2. And then from the axis down 1. So we went down 1 unit. So left 2, down 1 is what I'm looking for. G of x is the new one. G of x. So remember, we got the left and right inside, and we got the up and down on the outside. So let's just pick one of them to do. Let's do the up and down first. This is down 1. So on the outside, I need to have a minus 1. There's a minus 1. There's a minus 1. Those are plus 2 and minus 2. We didn't go down 2, so we're going to get rid of these 2. So these both went down 1. And then we went left 2. But remember, inside, this is the bad kid. So this is not left 2. This is right 2. And this is the bad kid. So instead of going right 2, he went left 2, which is what I want. So that's why those are really tricky, because the x number is the opposite of what you think. The outside one is up and down as it's supposed to be. Okay, so hopefully you're starting to catch on to the shorthand. But again, if you don't figure out the shorthand stuff and you don't get it this year, is it okay? Is it going to keep you from passing the STAR test? No, there are always 30 easy questions to do. These are not the easy ones. But if you can get these and remember the shorthand, these are a few more questions you can pick up on the STAR test. How does the graph of this one h of x equals 3x squared differ from the graph of the parent, f of x equals x squared? These are two equations I can put in the calculator. And when I go put them in, I can just look to see what happens. So these are the easier versions of these. So these are perfectly doable on the STAR test. You just go graph them and see what happened. And remember, this is always the first one. The parent is always the first one, no matter if they give it to you first or second. And this one is the new one. So you're just going to go graph them. And if you go graph them, the parent one was here. And the new one is still in the exact same vertex position, but the new one is skinnier inside of it. So this one, all it did was it got skinnier, and that was it. So this one says G. Oh, I'm sorry. You know what? They mislabeled these because the parent is F. And so they talk about F, but they labeled the new one H. So all these G's in here should be H's. The H got skinnier. The H got wider. The H went 3 units below, or the H went 3 units up. Okay. Now, did the vertex go up or down? No, it stayed right where it was. So this thing where it goes down below or went above is not right. This one says H is narrower. This one says H is wider. Remember, the new one is H, and that was the skinny one inside. The original one is my F, so F's on the outside, G's on the inside, and G is skinnier than F, so that's the narrow one. So it helps to know which one is which. Label them. F was their parent, and this H, I'm sorry, that should have labeled that H. I even did the same thing. So H was the new one inside. All right. Quadratic functions Q and Z are graphed on the same coordinate grid. The vertex of the graph of Q is 7 units below the vertex of Z. Which pair of functions could be used to create the graphs of Q and Z? Now, down here they have Q equals this and Z equals that. So these are Y equals, and I can go put these in the calculator. Notice that Z is my parent function, right? Okay, so before I go do this, though, I want to make a little picture of what they're describing. It says the graph of Q is below the graph of Z. That's all that happens, it's below. So I can visualize that one of them is here and one of them is straight down below it. It didn't go left or right, it just went down 7 units, right? I need to know which one's Q, which one's Z. It says Q is below Z. So Q is this one, and Z is this one. Now, which one of these is the parent? Z is the parent, right? So this is the first one. That means the new one, right? This is the new one, moved down 7. Okay, you need to know which is the first, which is the second. Otherwise, if this was the new one, you would have said if this was the parent function, you would have said the new one moved up. But this was the original one, the parent, and this is the new one, so it went down 7 units. So I'm looking for one, and I literally could put these in the calculator and see which one matches this picture. Just make sure that the Q is the one on bottom and Z is the one on top. Now I'm going to use the shorthand for this, and so over here, this makes it skinnier. This makes it go down 7, this goes up 7, and that makes it flip and get skinnier. So the one that went down 7 was B. And if you put those two equations in the calculator, they look just like this picture. All right. Other little topic that we have not talked about, but every now and then they throw one of these questions on the STAR test. We don't go over it a whole lot because it's one of, if we had more time, we would have done a few days on it along with that, I forgot what it's called now, linear regression stuff. But some years they have one of these, some years they don't. And so if it does show up, it's more of a reading type question than it is truly a math question. They want to know, they're using this word causation, which is cause and effect. Okay? Cause and effect. A good cause and effect that you will know about is if it rains a whole lot, does the lake fill up? Yes. And when it doesn't rain a long time, the lake drops in level, right? So cause and effect, something's going to cause something else to happen. And they're not looking for indirect things. They want something to be a direct cause. So they say which one does not show causation. So the amount of rainfall received and the level of the water in the lake. So the more water, the more the lake goes up, right? The less the rainfall, the less we have. So these are direct cause and effect. So this is a yes, and so I'm not going to pick it because we want to not. The number of lights left on each day and the amount of the electric bill. Well, the more that you use electricity, does the electric bill go up? Yes, it does. And the less you use, it goes down. So this is definitely a direct cause and effect situation. The increase of warm sunny days and the number of ice cream vendors visible. Now, just because it's warm and sunny, you may think, well, there's going to be more ice cream vendors out, but that doesn't necessarily mean that they're visible. They could be around the building on the other side. You don't know, right? So this is not a direct cause and effect. Let's read the last one and see. I'm kind of thinking this one looks a little fishy. The number of hours you work and how much money you make. Well, if you're getting paid by the hour, that is a direct thing, right? The more hours I work, the more money I make. The less hours I work, the less hours I make. So this is definitely a cause and effect. So which one was not the cause and effect? C. Sometimes they're fairly easy like that. Other times, like this next one, it's much trickier. I can't remember if this one is a direct. This one may or may not be as bad. But anyway, which does not, this is the not word again. So a bunch of these are going to be cause and effect, and one will not be. So that word causation has the word cause in it, so cause and effect. The number of tardies to class and the number of detentions you get. The more tardies you have, the more detentions you get. The fewer tardies you have, the fewer detentions. So this is a true direct cause and effect. The season of the year and the number of water-related injuries. Now, you may think, well, if it's summertime, you're going to have more water-related injuries. But I don't know that that's a direct cause. It could be something else that's happening there. So I'm going to kind of leave that one as a question mark. Let's see what else we have. As the temperature rises, if you have a thermometer with mercury in it, the mercury is going to expand, and then it rises in the actual little gauge. So it looks like it's going up in the little tube. So this is a true cause and effect. When the temperature gets warmer, that little mercury slides up the little scale inside the tube. So this truly does happen. And when the temperature goes down, it goes back down inside the tube, right? So that's a true cause and effect. The larger the dimensions of a rectangular patio, the more the square footage. As I keep increasing dimensions, because I multiply the two together, it's going to get bigger and bigger square footage. So this is true. It's a very definite cause and effect. So the only one that even sounded kind of fishy was that one. It didn't sound like it was a direct cause. Okay, so I'm going to put that as B. Which statement below might be caused by the statement, the more the furnace runs? Okay, so we want something that's going to be an effect because the furnace is running more. So the more the furnace runs, the less time the individuals will spend outside. Well, I don't know, just because I have the furnace running a bunch doesn't have any effect on people staying inside or outside. So I'm going to say that sounds kind of, I've got question marks on that one. It doesn't sound really true. So here's the statement again. The more the furnace runs, the longer you have to let your car warm up. The longer you will have to let your car warm up. Well, just because I've run the furnace doesn't mean it's cold outside and I need to warm it up. I could be running the furnace just because I've got a fever and I just want to stay really warm, or I'm sick and I just want to, or I've got a pet that needs to be kept warm, even though it's hot and it's, well, there could be other sorts of reasons why. I want to sweat it off or something. I want to sweat a bunch of water out. Who knows? Just because I have the temperature running on the furnace running doesn't mean that it's actually cold outside. So this is, again, another question mark. I really don't know about that one. The furnace, the more the furnace runs, the colder it is outside. Does me turning the furnace up and making it run more cause the temperature to get colder? No, it's actually the other way around. Usually the colder it is outside, the more people tend to run their furnace. So this is backwards. So I don't think that one works. I'm going to say no to that one outright. And then the more the furnace runs, the warmer the house becomes. Well, that is true, because if I run the furnace, that's the heater, furnace is the heater, the house gets warmer and warmer. So this is a direct result of me running the furnace longer. So this is the only one that is a direct result of that statement. So those are a little bit tricky, but they're reading questions. They're really not math questions at all, which is why I really don't cover it too much. If you get it, you get it. If you don't worry about it. Not if they happen to put one of those on the STAR test and you get it, great. If you don't worry about it. It's not going to keep you from passing. There are 30 easy questions, and that is not one of the 30 easy. Okay, the next 2 pages will be on the next video, so go watch the next video, and we'll go through the other ones really, really quickly because it's all old stuff.